So good morning to all. Today, once again, due to some connectivity problem, I could not connect in time. So let us start. Uh, in the last class, we have talked about the different theorems related to the DC circuits. Now, I would like to highlight one important point, that the things which were true for DC circuits were true for AC circuits also. Means they are true for AC circuit also. So, before proceeding to the definition of the different theorems related to AC circuits, okay, let's talk about the AC circuits. So today's topic will be related to AC circuit fundamental, AC fundamentals. Okay, so until unless your fundamental is not clear, okay, we cannot go through the other laws and theorems related to it. Okay, so let us talk about the AC fundamental. One thing I like to say that in the yesterday I was having some connectivity problem at my home, so I could not upload it. So I got it connectivity at my home also, so I will upload it today. So under this AC fundamentals, we'll talk about in very short, because you have already learned everything in your lower classes, but we will cover this topic in a brief way: generation of alternating voltage and current, alternating method for equation of alternating voltage and current, the waveform related to it, then different terms related to it. Then important point is the phase and the phasor difference, because now you have to know, you have to deal the complete AC circuits or the electrical networks when AC source is present, not by algebraic method but by the phasor method. Okay, so what is this phasor algebra? That we will discuss. Okay, then phase difference concept and other terms related to like RMS values, average values, form factor, and how to deal an AC circuits when an AC current source or voltage source is present to an network. Others we will also be discussed addition, subtraction of vector. Then what is the behavior of resistor, inductor, and capacitor when AC is passed through it. Then pure ohmic resistance, pure inductance, and pure capacitance. So everything will be deal, so that now then we can proceed to the AC theorems. That is all Kirchhoff current law, Kirchhoff voltage law, Hamilton theorem, Norton theorem, all the theorems, laws that we have studied in the DC circuit, the same are applicable to AC circuit, but with slight modification. And that modification is what? That instead of algebra, we will be using so-called phasor algebra. Phasor algebra are equivalent to the vector algebra, which you have learned in the physics for the mechanics. So don't worry about this. So you know how an AC is produced, that you have learned already in your lower classes. Okay, I am giving you a brief idea that when a conductor is rotated in a magnetic field, okay, then an EMF is produced across the terminals of the conductor. Okay, and this EMF is of alternating in nature, that is direction continuously changes. So this diagram you have learned, you have seen in your lower classes, where this is the conductor. Okay, this is the conductor, and this is the magnetic field, which is produced by the permanent magnet or by the field coils. Okay, and suppose it is rotated with the speed of omega radian per second, then we all know that an EMF is produced across its terminals, and this EMF can be of this shape, okay, can be of this shape, okay, can be of this shape, and can be of this shape. Now in all these four graphs, what you are seeing, the x-axis is the time axis, and the y-axis is the either voltage or current, whatever it is. Okay, and the one beautiful things or the new thing which you are seeing, that after a particular time, the magnitude of either voltage or current is the magnitude as well as direction is changing. Okay, magnitude is changing, no doubt, but magnitude changing with same direction with unidirectional will be called as in fluctuating DC, will be called as fluctuating DC. ध्यान रखना कि अगर आपका मैग्नीट्यूड चेंज हो रहा है लेकिन डायरेक्शन चेंज नहीं हो रही है, तो वो एक डीसी है, वो किस प्रकार का डीसी है, फ्लक्चुएटिंग डीसी। लेकिन यहाँ आप देखेंगे इन चारों ग्राफ में कि देखिए यहाँ मैग्नीट्यूड इंक्रीज हो रहा, फिर डिक्रीज हो रहा, डायरेक्शन वही है। यहाँ इस पॉइंट के बाद डायरेक्शन आपकी चेंज हो गई। सो द एसी मीन्स द नॉट ओनली मैग्नीट्यूड बट direction is also changing, or direction is also changing. But if magnitude is changing but direction is not changing, it will not be considered as an AC, it will be considered fluctuating DC. However, if magnitude is constant but direction is changing, then again it will be an DC, that it will be an AC waveform. Okay, so this is an AC waveform, it is clear. This is also an AC waveform because direction here changes. It was previously positive and now it is again it is positive, again it is negative here, again it is positive and negative. So these four graphs, what they are representing AC waveform. Any problem up to this, you can write down in the chat box, otherwise I will move further. If it is okay, then please write okay. Okay, let's move further. Okay, so now another waveform is being shown to you. It is a complex waveform. Okay, it is a complex waveform in the sense that there is a fundamental waveform. This dotted portion is the fundamental waveform which has a frequency say 50 hertz. Now we will take into account what is frequency. Okay, but before let us understand this is a fundamental waveform. Now its multiple is also present. Okay, multiple means say 3 times of the fundamental 50 hertz. So 3 times of fundamental is 150 hertz. So this is the fundamental waveform is also present. So overall waveform will be an AC waveform. Okay, but it will be in distorted form. It will be in distorted form. Another, if 50 hertz is also present, 100 hertz, that is second harmonic, is also present, 150 hertz, again it will be get distorted. So what you see that as the frequency get add up in a fundamental waveform, the waveform get distorted. So and cycle. So the first term related to, so it is very clear that if the direction is changing in any voltage or current waveform, then we will call it as an AC waveform. Now there are certain terms related to that AC waveform. Now mind it, I have shown you a conductor. In this conductor, a magnet, it is rotated in a magnetic field. Then you will surprise to know that every time you will get a particular type of waveform, and that waveform is nothing but that is called as an sinusoidal waveform. To develop the other type of waveform, AC waveform, you have to go for certain another technique. But whenever you will rotate a magnetic field, whenever you rotate a conductor in a magnetic field, you will always get a sinusoidal waveform. This is known as sinusoidal waveform because when we mathematically represent it, it represents a sine wave, sine, cosine. You have read in the trigonometry. So it is representing an sine equation. So that is why it is known as sinusoidal waveform. Okay, you can have a triangular waveform, you can have a square waveform, you can have an sawtooth waveform, but in most of the cases we will be dealing with this type of waveform, which is called as an sinusoidal waveform. I think so it is clear. So now we define certain term. The first is the cycle. Now what is a cycle? In fact, cycle means that when any waveform completes its one set of positive and negative values in 1 second, then it is called as in one cycle. Okay, for example, I will show you with the help of a diagram. Now everything we will be dealing now with the diagram, where the x-axis will be your time axis, okay, which will be in second, and your this will be the magnitude of the either voltage or it can be current. Okay, or it can be power also. Okay, so but let us say for time being we consider it as a voltage or current. Okay, so now say suppose this is sinusoidal waveform is there. Okay, it is because my pen is not perfect, so please ignore this distortion. Okay, it is assume it is a sinusoidal waveform. Now you see this is the positive part. Okay, and this is your negative part. Okay, negative direction. This is in the positive direction and this is the negative side. Suppose in completing this positive and negative set, it takes a time t is equal to 1 second. Okay, then it is called one cycle, and this one cycle is representing, okay, what? Hertz. The unit of frequency is hertz. Okay, so one cycle is nothing but a set of a positive and a negative values of alternating quantity. Okay, and one that is the this is a set, and if it completes in 1 second, okay, mind it, one cycle is nothing but a set of positive and negative values of alternating current, and if this one cycle is completed in 1 second, okay, is completed in 1 second, then it is called termed as an 1 hertz frequency. So number of cycles per second is termed as a frequency. Mind it. Okay. If this set of positive and negative is completed in 1 second, then we call it a 1 hertz frequency. If two cycles are completed in 1 second, then what will be the frequency? Please write in the chat box. If two cycles are completed in 1 second, then what will be the frequency? 2 hertz. Very good. Okay. If 3 cycles are completed in 1 second, the frequency will be 3 hertz. And you will surprised to know that you all know that in our household services and in India, in fact, what in household, in all the industry, in the agriculture area, in the home services, we are getting a frequency of how much? Can anybody can tell me? Please write in the chat box. Yes, 50 hertz. That is, you have to, in India, we are getting the electricity at a supply of 50 hertz. In America, it is 60 hertz. Why it is this? That we will discuss on some another day, but on some another day. But before this, it should be very clear that in India, we are supplying the electrical energy at 50 hertz. Now, what does this mean by 50 hertz? Again, now use this concept, okay, and tell me what do you mean by 50 hertz? If I say the frequency of electrical supply in India is 50 hertz, what does this mean? In USA, it is 60 hertz, but in India, it is 50 hertz. Very correct. Hardi Singh, very correct. Garvesh is very correct. Those who hasn't understand, I will explain. 50 hertz means that in 1 second, 50 cycles are completed, and one cycle is nothing and set of positive and negative. So 50 hertz represent that the 50 cycles are completed of this sinusoidal waveform in 1 second. Okay, that is what I mean by 50 hertz. In USA, it is 60 hertz. So all electrical engineers should have in the mind that in India, we have a 50 hertz supply, but in USA, it is 60 hertz supply. Advantage of 50 hertz is also there, disadvantage of 50 hertz is also there, advantage of 60 hertz is also there, and disadvantage of 60 hertz is always there. So don't get confused. Okay, never get confused. Now we come the time. The time is just the reverse of the frequency. Okay, so time, what do you mean by time? The time taken by an alternating quantity to complete one cycle. That is the time taken to complete one cycle. Now this is a sinusoidal waveform. Okay, see, this is the sinusoidal waveform. Okay, so this is a positive part. Okay, and this is negative part. So it is completing one cycle. Okay, so how much time is being taken? Suppose time taken T is capital T, then this capital T is known as the time period of the given waveform. Okay, today I will stop here. Okay, because I have started late and some another class is also going on. So let us complete this time period. So the time taken to complete one cycle is called time period and is represented by capital T. And there is a relationship between T and F. T is nothing but equal to 1 upon F. 1 upon F. Okay, so F is nothing but frequency. If the frequency in India is 50 hertz, then time period will be 1 upon 50 second. Okay, so it should be very clear. So today we have started the AC circuit, and we have come across the two concepts, the concept of cycle and the concept of time period and frequency. So because another class is going on, okay, so we will take it tomorrow, or if I will be available in the afternoon, I will tell you through WhatsApp after 4 o'clock. If I am available, I will continue this class. Okay, thank you very much for today's class. Okay, thank you.